Alright, you are welcome to this lesson, and in this video we have been asked to find the y dx of this function using the derivative definition. And it says that f prime of x, which is equal to what we call the dy dx, is equal to the limit as h approaches 0 of f of x plus h minus f of x, all dividing h. This is what definition says that we do. So let's do that. So what do we know? We know what our f of x is, but we don't know what our f of x plus h is. So how do we get this? This is gotten by saying where we find x in the expression, we put in x plus h there. So let's do that. So we have dy dx is equal to the limit as h goes to 0 of root of x plus h minus root of x, all dividing h. All dividing h. Now, what do we do at this point? Whenever we are finding limits, we always rationalize by the conjugate of the numerator. So we will always rationalize. So let's do that. So we have dy dx is equal to the limit as h goes to 0 of x plus h minus root of x all over h. This means that we multiply both the top first, the top and bottom, by the conjugate of the numerator. The conjugate of this man is just writing this man again, but in reverse sign, and the denominator by the same thing. Now then we can multiply out. So this can multiply this and this can multiply this. Now let's do this. You notice that this expression and this are almost the same, just that the signs here are different. Because of that, they are called difference of 2 squared. To multiply this, you say the first and the first, and the first and the first, as we always do, will always give us what is inside. So we have dy dx is equal to the limit as h goes to 0. This by this is s plus h minus this by this is simply x all over h by this is simply h into x plus h, then plus root of x. What can we do here? We can subtract by saying x will cancel out x here and x cancel out h here. So we have dy dx is equal to the limit as h goes to 0 of 1 over root of x plus h plus root of x. At this point, we can take our limit and see what we get. Limit as h goes to 0. As h goes to 0, so we have dy dx is equal to 1 over root of x plus 0 plus root of x. So you see here that we have root of x plus 0 is simply root of x plus root of x will give us twice that value. So we have 1 all over 2 root of x here. So this will become 1 over 2 root of x, which is the dy dx for that function. Now, to differentiate root of x, what we are going to be getting is 1 divided by 2 root of x, even if you do that with respect to x. Thank you, and see you in the next lesson.